Good morning to the third and final day of this amazing Atlantic AI Summit. My name is Stijn de Baardemaker. I am Associate Scientific Director of formerly RITS AI. RITS AI is now there. Okay, we're now there. And I'm also a quantum chemist. And a small thing that I wanted to add here is I also have a small degree in arts and fine arts. And the reason why I got that degree is because I think it's very important to combine all that like STEM stuff and that logic, rational technology and science with art and that human touch to it, right? And if there's one place in this day and age where that has been like fully embodied is the Media Lab at MIT in Boston, a little bit south from here. Now, Alok got a tour of the Media Lab quite recently, a couple of years ago, by our keynote speaker, Dr. Hossein Rahnama. And it was so wonderful that Alok said, hey, you have to come to our AI summit and show this to our people. And our speaker said, I'll do anything for Canada, if I'm well informed. Okay. So it's an honor for me to introduce Dr. Hossein Rahnama, the Rogers Chair in Artificial Intelligence, AI, and Human Creativity. So that combination at TMU, Toronto Metropolitan University. The list of accolades is long, so I couldn't memorize it, so I have to read it from, but please bear with me. So Professor Rahnama is the Rogers Chair in Artificial Intelligence and Human Creativity, I just said that, and a visiting professor at the MIT Media Lab, where he leads the Sapien program, the human program. Beyond his academic roles, he's the founder and CEO of Flybits as well, an innovator, an AI and data science company specializing in complex, data-driven solutions and large enterprises. His research expertise lies in the design of human AI, agent systems, data governance, human HCI, human-computer interactions, and the development of mission-critical AI systems. A prolific author and inventor, has published numerous papers and holds many patents in computers and data science. I recommend checking them out on Google Scholar. It is impressive. He has been recognized with numerous accolades, and here we go, including being named to the MIT Technology Review's Global TR35 list, the Smithsonian Innovators to Watch, Canada's Top 40 Under 40, along with the Isidore Sharp Outstanding Graduate Award in 2013. That was Professor Rahnama. Currently serves on the board of Havergal College and Seal SQ, NASDAQ-listed semiconductor company focused on post-quantum chips. So I can relate to that as a quantum chemist. His past service include roles as a council and board member at NSERC, our national funder, Canadian Science Publishing, a publishing house close to my heart as well, and Home Capital Group. He's also a member of the Institute of Corporate Directors, holding an ICD designation. Please, Dr. Rahnama, come forward. The floor is yours. Here's a cup of water.
Chancellor McLaughlin, members of the UMB community and representative of the government, it's a pleasure to be here with you. I met Alok about a year ago, along with Dr. Karj, and the rest is history. He told me more about your university. Yesterday, I realized that UMB has the oldest computer science department in the country, so that's another privilege to be here. And I should say, like, your campus has been one of the most welcoming that I have ever seen. So thank you very much for your welcome and your hospitality. What I would love to do is to tell you a little bit about our work. A lot of it, of course, is my students' work, and I take the credit for it. And then tell you a little bit about a Canadian lens in terms of how we can learn and how we can lead. I want to take you back to about 20 years ago. I can't believe how fast time is moving, to our AI lab. This lab at Ryerson back then was called Computational Intelligence Initiative. My supervisor was Jeff Hinton's student. So I grew up with that very classic mindset of neural networks and AI. And my master's thesis was to build expert systems embedded in electronic medical records, allowing general practitioners in remote parts of Canada to diagnose cardiac diseases. So as they were using these systems, we could measure the risk of misdiagnosis as a GP was talking to a cardiac patient. You can see some of the models back then, our team. And the way I ran these models and trained them, you may remember Sun Solaris machines, these black box, gray boxes back then. I had to let the models run the night before I left the lab. I showed up in the morning and the models were ready. Just as a test, I used the very same models about 4 months ago on an OpenAI cluster, and it took about 20 seconds. The reason I bring that up is that, unlike what many people think, of course, outside the university ecosystem, the type of AI that we use now has been in development for the past 50 years. The algorithmics are not new. Even the transformers are based on neural networks and many things that happened before that. What has really changed is the ecosystem around AI, the computational capabilities that we have, ability to move the data, tools that we have that even non-computer scientists can use. So things are changing. I will fast forward and bring you to about the 2010 era, where it was the very first year that I became a faculty member. And we started to use a lot of that know-how around this notion of pervasive and ubiquitous computing. This is a time that mobile phones and iPhone were becoming the main digital channels, and it was a very fun time. We built augmented reality solutions that could navigate people in an indoor space without using radio signals. So you could arrive at the Vancouver airport, look at signage systems, and based on your itinerary and context, the augmented reality navigated you. We built the very first contextual navigation tool for the Paris metro system that became live as a Canadian group. I don't want to talk about working with the French public sector. That's a different story. But there were fun times. We had coffee machines in our lab that measured the stress level of our lab members and changed the intensity of their espressos. So they were interesting. And then we turned that into a company that were ranked alongside the Spotify, Pinterest, Dropbox. We won the Harvard Business School business plan competition. But after that, things changed, primarily because of our relationship with data. In all of those environments, we assumed that we have the data, we own the data, we control the data, we can do whatever we want with the data. That era is over. Where we are now, if we do not understand the physics of data, the legality of data, the privacy of the data, no matter how advanced our AI algorithmics are, it will fail. And I think understanding that data ecosystem is important before adopting any AI strategy. So these are some of the 8 principles that we follow in the design of our modern systems. The shift from personalization to participation. You may remember how we use Google ads. Oh, they look at a lot of data in a black box and they push things to us. How many of you are using these Gen AI tools, ChatGPT, Gemini, Claude? You're collaborating, you're participating, you're co-designing, which is great. That's a new user interface. But what should happen beneath the surface for that data to be protected, to be controlled, to be put in memory, for the context to be captured? We need to build a whole new set of ecosystems behind that. There is a need for transparency. it's always good to send data to these black boxes, mostly run by Bay Area companies. But imagine what you can do with healthcare data in New Brunswick, with energy data in Alberta, with fisheries data in Halifax. How do we control that, and how do we maintain auditability and transparency? That's a huge area of interest. If you think about Canada, and if you look at data as an asset class, imagine that we can have our telecom operators, our banks, our insurance companies, our airlines, all come together to form alliances using data as a fabric. Not putting all of that data in one place, calling it data lake. Keep the data in your own respective repositories, but allow the user using consent for that data to be shared on their behalf to generate you new experiences. That is gold. Those are things that, for those of you in computer science, in the legal department, can really focus on to build next generation ventures. So as part of that, I created a program called Sapien, Sapien with AI. So it's about human and AI collaborating based on 5 key pillars. Number 1, look at AI as an ecology. This is no longer an IT problem. You cannot go to a CTO in an organization and say, bring some AI and do some magic. It needs people from different disciplines and groups to come together to truly look at AI as an ecosystem. Think about an oceanic ecosystem. You have independent components working in tandem. That's the approach that we should have when we think about AI. Many people ask me what I'm worried about. To be very honest, I'm not too worried about the technology of AI. I am extremely worried about AI literacy. Educate, educate, educate. That's why where we are now, and places like universities, even K-12 schools, are going to be the next generation enablers on what we can do with AI. Going from corporate directors and public policy leaders all the way to junior school students, telling them what AI is and is not. People think, of course, it's rightfully that AI hallucinates. I think people hallucinate more about AI than AI about itself. So those are important things to educate, and you don't need to be a computer science student to do that. It's understanding that philosophy. We talked about data, but also when it comes to post-secondary institutions, which we will have a panel about today, think about disciplines that are huge opportunities to evolve. One of my favorite ones, design. Many of you use apps, corporate apps, consumer apps. How are they designed? In a very prescriptive fashion. People do wireframing and focus groups and get together and test it and A/B test it, and they launch it. We are now at an era in which you're throwing terabytes of information on a 2-dimensional screen, and you want that information to be personalized, contextualized, auditable. Who's designing for that with these uncertainties in mind? That's a huge discipline to be able to design for AI and build AI systems that are more decision supporters than decision makers. So as a result, we created something called an AI spectrum. I remember back at Ryerson in 2001 when I was an undergrad intern, they took us to a room and they wanted to show us a platform called Access Grid. We sat in a room like this. There were about 20 universities from around the world. Each of them was represented by a grid of videos, and they were talking to each other. Literally, I sat down like, wow, this is the future. We now take that for granted on our phones, doing Zoom calls, almost irrespective of where we are. One of the reasons for that is that we invested significantly in communication spectrums. We now have, in Canada, in certain parts, we are very advanced when it comes to our connectivity infrastructures. We have wireless frequencies, we have 5Gs and soon 6Gs. Those are great. There are regulations around that. We should think about AI like that. What is this new concept of a spectrum for AI, which of course includes technicalities and algorithmics, but what about privacy? What about abstraction of systems? Who said that you should get rid of your COBOL systems? By the way, if you're in computer science, if you're looking for a COBOL job, that's one of the most highest paying jobs that you can find in Canada because all the banks are looking for them. But you can keep all those systems, but you can invest in abstraction and orchestration. That's what AI is very good at. One of the things I want to talk about today is my core research around this notion of human AI service agents, which is not in conflict with what we see in the Bay Area and especially with LLMs, but our hope is that this is going to augment it. If you think about how you use LLMs, we use it like this. You have billions and trillions of parameters and attributes being classified, usually in a black box. Of course, you can use open source models. You put them behind a conversational interface, and as an individual, you communicate with that knowledge base, which is great. That will continue to stay. But think about this. Imagine every single one of you can be represented by a model. We call these AI Chronicles. These are new data structures. These are reason-ready neurosymbolic graphs that can learn from you. They're protected. You can even host them on an encrypted neuro chipset on your handset, and it will be representing you when needed. So the goal we have is, of course, you can use LLMs, but what if I have a question about UMB and Alok is not available, but I can activate his chronicle and ask him a question? And I have a social and legal contract with him that he allows me to have certain level of information access to his chronicle. Today I was talking to Dr. Karch, a well-known orthopedic surgeon. He's in California. I don't have the privilege of accessing him all the time, but what if he's okay, instead of sharing his Instagram account with me, he's now willing to share his chronicle with me. So I don't need to go on WebMD or LLM, I can ask him a question. Imagine every single one of us as an individual, but also entities, our companies, our communities, our neighborhoods, they all have these knowledge bases that can be controlled, privacy preserved, and shared using proper legal contracts. I don't want to bore you a lot if you're interested. I always love to talk to computer science and engineering students. If you're interested in that, you can go and read some of these papers. But in a nutshell, we are building these multimodal systems that can process different modes of data. Think about text and images and CAD drawings and music. You can keep adding different modes through pre-trained models. You will vectorize them. And then over a period of time, you capture behavioral patterns and subgraphs. And if there is a pattern, you reason to it and you add it to the chronicle over a period of time series. We do these based on behavioral ontologies. So this is what my research team has been focused on for the past 10 years. How do we understand human behavior from a base level, personality traits, emotion, affection, empathy, but bring it all the way to the very top to make it more industry specific? Ontologies for mining, ontologies for healthcare, ontologies for finance. How many of you are from a computer science department here? Okay, brilliant. I don't know about UMB, but the three universities I worked at, like U of T, Waterloo, MIT, and Ryerson, within the Department of Computer Science up until about 10 years ago, there were two groups that, again, I'm not saying here, in our cases, they didn't like each other. People who were doing semantic computing and people who were doing classic AI and neural networks. They deviated their approaches in terms of their view of the world. It's about 10 years that those two substreams are combining, what we call neurosymbolic systems. So the great thing about that is that we don't need to go and build these ontologies from scratch. Using these techniques that I told you, we can go about our daily lives and these ontologies gets updated. So for example, at a hospital, the more procedures you perform, the chronicle gets better. And it contributes to that broader ontology. So now I'm going to give you some examples. One of our work is to think about the future of work. The two-dimensional org chart that you see here is familiar to all of us. Hierarchical, project comes in, people get together based on budget, calendar, availability, and then we perform that task. Imagine that in an organization, every single employee is being represented by their representative trusted agent that has learned over time from their work. When the project comes in, think about it as a prompt with a large context window. Are the agents now coming together to perform part of that task, not the individuals? But the agents, through orchestration, they bring that project to a level of completion that is now going to be passed to the representative humans to complete it, to finish it, to make it more innovative, to polish it. So the people don't need to be in their cubicles 9 to 5 to do the same thing. They can come to events like this while the AI is doing their work, take this knowledge back and improve it and innovate on top of what AI can already do based on existing knowledge base. This is an early project, but our thesis is AI does not need to replace our jobs. It can augment it, but we should understand it. This binary view that AI will kill all jobs, yes, it will kill jobs, but we can be smarter than AI and just use it for what it can do well, incremental procedural work on existing knowledge base, and we spend our time on innovation. I'm going to show you a few more examples on the future of work, and we'll go to a few other verticals. Just want to move forward here. So I have a student who was the former VFX director of Harry Potter. So he loves spatial computing, immersive computing. And it's always great to bring these disciplines together to see what happened. So he's now helping me to create the digital twin of an indoor space. We used to use LiDAR, but now we can use techniques like Gaussian splatting, which you can use essentially a good iPhone camera and build an indoor mapping, a digital twin of a space. The video that you see on the left is our spin-off office. The video that you see here is the digital twin representation of that, built within about 12 hours, give or take, just by iPhones. This is a tool that we created called Open Dome. I didn't want to call it a metaverse, so it's a dome connected to open data. Then we said, well, let's see if we can create the digital twin of this office. Which company can we work with that is going to give us HR data, payroll data, project management data? No company will ever do that. So we said, okay, let's use our own data. Let's do things like homomorphic encryptions and all that to protect the privacy of our employees. Let's create chronicles from the office, from about 12 systems of records. And then we built a tool that you can now go to the digital twin of that office. We created a syntax called iGenerate. So if you think about Twitter or X now, you know the syntax. You know where to use handles and hashtags. In our case, you use a syntax called iGenerate. So iGenerate curly brackets, the model you want to fine-tune from the lens of someone else. So in this case, we use Chronicles as lenses. You can go to the office and say, today I want to see the office through the lens of the CEO. What is important to the CEO today? I want his perspective. Now, if I'm a member of the executive committee, I have more information. If I'm a junior intern, I still get information, but the level of granularity will be different. Or you can go and look at your ESG metrics through the lens of the ESG experts. What we're planning to do, I don't know about you, but I have challenges that a lot of our new employees do not want to come to the office every day. If you can solve that problem, let me know. But we thought, what if we can create a spatial environment that brings the mentors and mentees together with a bit of a spatial understanding, allowing them to learn from each other, even if they want to work from home. If you visit the MIT Media Lab, we did the same thing for our research lab. So we created a fine-tuned version of our researchers. You can come to the digital twin of the lab. You can say, I want to look at this group or this paper, but I want to look at it through the lens of a climate researcher, or I want to look at it through the lens of a medical researcher. So the research paper is the same. You develop different perspectives of that based on the profiles of the professors or researchers that are giving you access to that. Think about politics. I'm looking at a document and I want to look at it through the lens of this party or that party. But at the end of the day, I will make my own decision. I'm just consulting perspectives. We use it for idea generation. I have a colleague who is a world-renowned person in genomics. That's definitely not my background. I can use our two representative chronicles, bring them together, and come up with a new idea for a collaboration. So when I meet him, I have a lot more to make the most of that meeting rather than starting from scratch, because we are using these perspectives to make our human-to-human communications more effective rather than the old HCI, which is just human-computer interaction. Now, I want to take you, everything that I showed you up until now, they are built and developed as what I call screen AI. They are usually being hidden behind screens like that. There is a documentary you can watch. It's publicly available now. It's called Post-Human. It's done by Bloomberg. And they reached out to us and Jeff Hinton and a few others and said, we want to see if we can actually create a version of a real person using your chronicles. So I'm going to play a quick excerpt from that video for you, and then I will tell you how we did that. So these are some of the early development of that to connect these chronicles to a spatial environment. But let me play a quick video for you, and then I will tell you how we did this. This is part of the documentary if you want to watch.
Realistically, give us a form of immortality.
Chatbots can be immortal, but immortality is not for people. People are analog systems. Nobody can replicate you without precisely replicating all your hardware, which is impossible.
So, for example, I lost my father at a young age. If I could speak to some digital version of him that felt like him, I think I'd love to do that.
In order to do that, you'd need to train up a chatbot on lots of data from your father, and I'm not sure how good it would be.
A group of computer scientists is doing just that. By gathering every bit of information about your life, they recreate an AI version of you that can live long after your hardware gives out.
Hi, Emily.
So what we did, Emily reached out to us. We worked with her, and we used our chronicle builders. Again, these are part of papers if you want to read. First, what we did, we created a priori graph or a priori knowledge base. So someone like her, she has interviewed all the major Fortune 50 CEOs. They are available. Of course, we had to work with lawyers to make sure who owns the data. That was another great learning experience for us. But if you look at here, first, we used publicly available data to develop a chronicle and a representation and an embodiment of her knowledge with their permission, of course. Then we continued to use additional data as things emerged on the media platforms, her interview with Natalie Portman, with Sheryl Sandberg, her books, documents, social media. And then we created an agent. First, it was a chatbot. You could talk to the chatbot, and they validated that it's pretty accurate using these Chronicles. So what I did with my team, we're like, how can we take this to the next level? We reached out to folks in LA. These are the folks behind a lot of Hollywood movies, Avatar, the movie. So we are like, what if we join forces? What if we bring the best of our know-how on behavioral modeling, and you help us with your facial expression mapping? We don't need to disclose IP to each other, but what if we fine-tune our models against each other? This is especially for students, and I love working with students. This is a huge opportunity for you for your future careers. This is the power of AI. You don't need to do everything. Build a very niche capabilities, and you can quickly tune it with other capabilities. So if you build a next generation incubator, if each group is focusing on one thing, putting them together to create a new thing out of that or create a fusion is way easier than 10 years ago. So this is what we built. This is an example of an interface in which, instead of talking to ChatGPT or Gemini and Claude, you essentially have access to chronicles of your collaborators or your colleagues. In a hospital, these could be doctors. In a bank, these could be financial advisors. In a university, these could be professors. When you choose them, based on your permissions and legalities and what you have access to or not, you will access the chronicle that you can process. We also work with some ethics groups and also privacy groups to create something called the audit dashboard. So as you're communicating with these agents, exactly how we have what we call gut feelings or sixth sense, you develop a sense of trust. So we don't tell you what to do, but we look at provenance of the data, validity of the data, verification of the data. There are about 8 metrics that we look at to give you this view on how much we think you can trust what this agent is saying. So I'm going to play this very quickly just to show you a quick demo. You can prompt, you can choose your chronicle, you can process the chronicle and get the trust.
AI appears almost magical in the workplace, enhancing productivity and streamlining tasks, but it brings significant concerns. The training data driving these systems can be biased, racist, sexist, and incorrect, which may perpetuate and even exacerbate.
So, the other thing that we learned through this, these deepfakes are extremely dangerous. Especially if you think about kids and our kids, we need to educate them, we need to protect them. Of course, we have done a lot of technical work, like for example, in the demo I showed you, there has to be a watermark and an encryption key and many things for that chronicle to load to the interface. But as I'm seeing what's happening around the world and with some bad actors, those are the things that we should learn how to use, but also educate how to protect people, especially kids, with the advent of these technologies. I want to talk about 2 quick verticals. Of course, we have done a lot of work in finance. How many of you heard about the notion of open banking? I think it's a huge opportunity, but unfortunately, in many cases, our big banks and governments think that, well, either we have to give up data to the fintechs, and fintechs are pushing for accessing the data to go head-to-head with big banks. But again, if they find this synergy, we can create this whole new ecosystem in Canada that does not exist. So let me give you an example. This is the notion of decentralization of data and how decentralized models can create new economic opportunities. How many of you use mobile banking apps? They're awful. They're the worst software engineering nightmares that were ever invented. In this particular case, this is in the US, So we used open banking to access all financial data assets that you have. You may work with 3 banks and 2 credit cards, and you have pensions and all that. You can aggregate all of that without co-locating them and looking at them. Then our students have gone and built not large language models, but very small models that do very specific things. I want to do vacation planning. As a parent, I want to save tuition for my kids. These are all models, could be clustering models, predictive models, doesn't matter. So now you can have a conversational interface that you can plan your life. So our goal is that every single Canadian should have access to their free financial plan. Everyone should be able to create a financial plan. But now, instead of you going to a bank, you have a token that represents your financial plan. The banks should bid for your business. You're like, who wants me as a customer, big 6 banks that 90% of the Canadians bank with you? You flip the business model. Now think about the business students here. Think about all the business opportunities that you can create here, from exchanges and all that. Fintechs win, small businesses win, banks win, all because we have a view on data decentralization business models, and we need our public policy leaders to understand open banking does not mean someone loses and someone wins. It needs this literacy to be able to bring regulation and business together. My team also created these spatial environments that you can go to an immersive environment, activate not just your banking data, but let's say your mortgage data, data from real estate and all that, and start planning. Oh, I want to buy that house. How much should I save before I can buy it at the age of this? You can go through this in this metaverse or open dome, capture it as a token, go to the branch with your phone, tap it on an RFID, and your financial planner will see your intent. If you don't have that, your financial planner will show up with a dossier of 100 pages, and it will take 2 hours for you to get to the 20% of what you can achieve with this. This is what I call HCI2, humane, calm, and intelligent interfaces. AI in the background allow us to communicate with each other more effectively. Again, I told you my team really disliked mobile banking apps, so they said, let's imagine a world that we can use the best of AI with no apps. So we worked with a card manufacturer in France, and we said, well, we are going to use augmented reality glasses connected to the cloud with the fine-tuned LLMs. We use gestures on a card, and I actually look at my card and get everything that my mobile banking app gives me without using any apps. This is a concept at the moment because we have some issues with the latency of these augmented reality glasses. Huge opportunity, but also it gives you an idea that in 5 years, as the chipsets are becoming better, this could be a way that we can embody AI into all sorts of objects. Now let me go to the last two. This was my COVID project. I had more time. These are my daughters. They have grown up since then. This is an old robot. Some of you in computer science may have seen it. It runs a Linux, so I embedded some of these Chronicles into the robot with a USB key. But as my kids were interacting with the robot learned them, and I could also incorporate things in the robot for them to learn, and it was multimodal. But the story I want to share here is this was a hobby project when I started it. About 7 months ago, a doctor from Sick Kids Hospital in Toronto saw this and said, this can be huge for children with autism. Because his research was children with autism have social anxiety, and as they are learning, they respond better to humanoid robots during those early days rather than having someone as a human working with them. Something like this just went to that group, and now they are taking it to the whole new level. This is where I think the role of a university can shine with industry partnership. Let us explore, interconnect us to the ecosystem, let us amplify, let them to figure out use cases for that. Now the last, but in my point of view, the most important one, which we can have the highest impact for Canada, is the combination of AI and health. So we have done some work based on what we learned with, for some reason, I don't know, our team likes very complex regulated environments, banks and healthcare and defense, but our view is that if we can figure that out, things will become easier in other verticals. So in the past year or so, we have tried to agentify a lot of the systems that are currently monolithic, from basic things like patient metrics, scheduling, communications. So after I met Dr. Karch at MIT, I'm like, After my master's, I gave up doing anything with AI and healthcare because it was impossible to get access to medical records. But after I met him, I'm like, okay, let's give it another shot. So we started to think about first human-doctor interaction. So we thought, if we can have about 20, 25 years of electronic medical records, can we think about the agentification of a doctor's knowledge so he or she can go and communicate with the patient? One of my favorite meetings was through Dr. Karch's group. We met with a group in Washington, D.C. that their focus was on bedside manners. Like, what is the relationship that a doctor should create with their patient? It's very contextual, right? Like anxiety level, the type of diagnoses. They had a lot of data on these interactions, and that became a perfect thing for us to embed it in the model. So it was very interesting that one of our experiments was that if you have a sad chatbot, the human element will actually be more motivated to make that chatbot happier. It's very interesting. A sad chatbot makes the human being actually more motivated and persuasive, which was an interesting outcome from that research. Then what we did with the Chronicles, we said, well, let us see if we can do consultation. So if the way this works is, let me go back. These are the real doctors, and some of them are patients and some of them are doctors. And when it says H, it means it's a human. When it says C, it's the chronicle representing that doctor. So now, whether I am a doctor or I'm a patient, I can activate all my chronicles in a chat interface and perform a consultation and a conversation. So as a patient, I can say, I want a dermatologist, my dermatologist. I want a cardiologist, my cardiologist. I activate all the chronicles and ask them questions. Or a doctor can say, I want to activate the chronicle of 3 of my colleagues who have expertise, and I want to talk to them. Technically, this is very possible. What we are learning now is, well, how do we build this as decision supporters rather than decision makers? How do we make sure using FDA and other health regulators that these are not diagnosing, these are just helping you to figure out edge cases that you may not have it in your radar because maybe your hospital told you, you only have 15 minutes per patient. Can we keep that 15 minutes? But these systems allows you to go to that decision faster and also be aware of what may go wrong. We are doing things with simulations. These are some of our early work that I have a student interested in that, to build the digital twin of a patient to figure out, based on different metrics of biomarkers and blood markers, what type of a symptom may show up in persons face or subjective data. This is a bit of a fun one. This is one of my design students. He's very interested in nutrition. So he looks at how different types of nutrition based on genomes may age you. So he's developing different diet plans, give it to the agent and says, show me how am I gonna age in the next 30 years? How am I gonna look if I follow this diet versus that diet? Very early prototype, but it's an idea that I develop perspectives. I don't need to be biased on an echo chamber. I can kind of predict how it may affect me. Now, he's wearing a mask, but you may recognize him. That's Dr. Karch. So about Dr. Karch, can I ask you to come and join me? So about 5 months ago, we said, let's just give it a shot. Let's build a living lab to see if we can actually recreate you. And he was very welcoming and very collaborative. So we tried to create a digital version of Dr. Karch and going through a model to see whether he is better or his avatar or they are at par. So maybe say a few words on our collaboration, and then we'll go back and forth and see, how are you at par with your digital representation.
You want me to talk? I can talk.
Yeah.
We can say, hi, I'm Dr. Karch. I'm an orthopedic surgeon, and this is the real version of Dr. Karch. Hi there. I'm the AI version of Dr. Michael Karch, who's an orthopedic surgeon. Just to be clear, I'm not actually Dr. Karch.
So, and then on a more serious note, we are also thinking about how can a patient talk to him when he's not available, or maybe his or her appointment is in 2 weeks. And in some cases, I talk to an oncologist that, especially with breast cancer, when that is being detected, the level of anxiety is so high before the patient meets with the doctor that we are like, what if there is a level of continuous consultation until the human patient meeting happens? So we are not thinking about those types of consultation, which are things like that.
My name is Dr. Michael Karch. I'm an orthopedic surgeon at the Mammoth Orthopedic Institute in Mammoth Lakes, California. Today, you're speaking with my AI clone about some of the issues you've been experiencing. From what you've described, it sounds like IT band syndrome. The IT band is a...
So the other idea that we had was, one of the requirements, I don't know why the university... Yeah. You're nicer. Your real one is nicer. One of the things that I told him it's a requirement for him to come to New Brunswick is that he had to be bilingual. And he told me, hey, that may be a problem. So we said, okay, let's see if AI can solve that. So we actually had someone came to us at MIT and said, you know what about cultural nuances? What about language barriers? What if there is someone somewhere in the world who really want to talk to Dr. Karch, but may not have the opportunities to fly to California? That was a great idea. So we said, how can we use his knowledge base, but tune it with language, cultural nuances to make sure that we make it more inclusive? Do you speak French?
I wish I did, but I don't.
Okay, so this is how we did it to address that problem, especially in places like New Brunswick and Quebec.
Je m'appelle Dr. Michael Karch. Je suis chirurgien orthopédique à l'Institut orthopédique de Mammoth, à Mammoth Lakes, en Californie. Aujourd'hui, vous parlez avec mon clone IA au sujet de certains problèmes.
All right. Well, this can fix it. Thank you, Michael. Yeah. I want to wrap quickly. So,
Hi there. My name is Dr. AI.
Enough. These last two things, this is very important to me. So about 4 months ago, 2 professors from York University approached me and said, there is someone who used to run the palliative care for Mount Sinai Hospital in Toronto. He now lives somewhere very remote close to Ottawa, and we want you guys to meet. I was uncomfortable, he was uncomfortable, but he has written a lot about essentially what he calls the beginning of ending, people's regrets and things that he has seen. And although I don't want to make it dark, I went there and I spent about 5 hours in his farm talking to him. And it was so telling that I went back and told my students, we cannot build systems in the confine of a computer science lab. We need to really understand people, emotions, regrets, empathies. And if we find a way to bring these to these AI systems, then there is a chance to scale these effectively. The last thing, the most important thing, students. These are the people who will build the future. We can pave the way. We need to empower them. There are things that we don't know. There is no playbook out there. I think the role of many of us in education will become the guide on the side rather than the sage on stage. The tools available, access they have, is changing university ecosystems. So we are now building programs like super courses that students from fashion and AI and mechanical engineering and business coming together to innovate around AI, to think about prototypes. I had film students who created a news channel using AI. They were film students. I learned a lot from them. So one of the things I would love to work with UMB is that let's do more of this across Canada. Let's bring our students together. Let's create mobilities. Let's create hackathons and things like that. And then we are building tools for them, so what we call an AI readiness graph. The thing with AI now is that you can always hear talks like these, can be inspiring, but the question is, what should I do next? What's the next step for me based on the DNA of my organizations? So we are now working with people now to create tools so you can assess where things are and what you can do next to improve the readiness and empowerment. And the last thing, I promise it's the last thing. I wrote a paper, you can read it, it's called the Canada AI Framework in October of 2025. So I use Canada and every letter on the things that we got to do to lead. And you can read that paper. I think our federal government announced a few things. They used the term that we use called AI for all. So I'm happy that they listened. But these are some of the things that we can do to lead as a country. We need collaboration. Collaboration between universities, collaboration with startups, collaboration with companies. We need to think about our advanced algorithmic capabilities, whether it's quantum or non-quantum. Don't go build another language model. We cannot compete. We should not compete. We should double down our own assets based on the powers and the values of each jurisdictions we have. Nurture talent, create applications and adoption. You can now build applications without writing a single line of code. Let's see more of that. And then teach and embrace data governance and ethics and control. Because by knowing that, we will be able to build these effectively. And of course, think about AI for all, from that small business owner to that elderly, to that amazing computer science student. We need to think about it as a spectrum so it empowers everyone. Thank you very much.
Wonderful, fascinating. Fascinating talk, the glimpse into the future. I'm sure my students would love to talk with the Chronicle of me when their paper is stuck on my desk. I apologize profoundly. I know I'm eating into the break, but I entertain 1 or 2 questions, please. The microphone is in the middle. 1 unless everybody's so.
I think
So,
We're getting on with personal context, I'll say, with the LLMs today. You're taking it to another level. How close do you think we are with the work we do inside of Claude to set the context as best we can in order to have the agents? I'm just interested in what you think.
that's a very good point. That there are two lines of thought, and I share my personal view. I don't know which one is right. One view, which again, their holy grail is we will get into a general artificial intelligence, is that there is enough data combined with what's available in the local memory that we will be able to do everything that I just showed just by relying on LLMs. The problem with LLMs is that they're good in so many things, but one of the biggest challenges with LLMs is that it's very difficult to unlearn. As human beings, we unlearn, and we can unlearn one thing and relearn that. In text-based LLMs, that's becoming more addressed, but if you think about visual language models, if you generate an image and say, I don't like that part, you can't change that. You have to regenerate the whole thing again. With the Chronicles, you can do that because every single component of that reason-ready graphs can be tuned and managed, extracted, plucked out. So I think there is going to be a hybrid world for so many different reasons that these LLMs will become better and better. You can use LLMs for how to say things, but for what to say, especially in regulated and mission-critical environments, you can use not Chronicles, systems that you control and own, which are not necessarily LLMs, but bring them together into an orbit and just add more planets into that orbit as different models.
wonderful. Thank you so much. Please join me in thanking Dr. Rahnama.
Thank you.